All right, well, welcome back. We're going to dive back into Python for text analysis. Up to this point in this workshop, welcome back, everybody. Thanks again for joining us. We have covered quite a bit of ground in the process of this workshop. Now, most of what we have been doing is pretty basic Python, right? We've been learning syntax. We've been learning just a little bit about how you build out a program to do something in Python. Today, we're going to continue where we left off yesterday, and we're going to continue to introduce innovations, and we're going to make what we're doing a little bit more advanced. Now, I'm approaching this workshop in the same way that I approach the classes that I teach, where I'm essentially showing you how to do something with pure Python that can be made significantly easier with the help of external libraries. And so once we finish up where we left off last time, we're going to start talking a little bit about those external libraries, and then I think we'll talk about how to use the natural language toolkit. And then that will leave us for tomorrow as the last day as a time to think about more advanced analyses and visualizations and using libraries that are a little bit newer than the natural language toolkit. Nltk, as it's known, is a really useful library that comes with Anaconda that does a lot of very good natural language processing, but at this point it is kind of showing its age a little bit. Most people, when they're doing NLP, tend to use libraries that are not quite so, that they haven't been around quite as much. And a really popular one of those is Spacey. We'll talk a little bit about that tomorrow. Another really good place to go for code that will help you do natural language processing is the Stanford Natural Language Processing Group. And they actually have a multilingual toolkit that will do a whole lot of the things that you might be interested in. But we'll continue to kind of work our way towards that point. Just as a quick reminder, I'll show you my desktop here. All of the course materials are on GitHub and at on my page at from 0 to N. And I have added this to the description of this live stream. So hopefully this time around it will be a little bit easier to track down. And I have uploaded everything that we have covered so far. In from 0 to N, you'll find all of the scripts that I've written so far, as well as the Chinese, English, and French text folders. I'm going to show you today how to access files inside those folders, multiple files at a time. What else? I've also added links to all of the streams from the GitHub page. That way, if you want to go back and rewatch something, that's an option. I will be at some point going back into the streams that we've recorded and adding timestamps. So, for example, I would add a timestamp where I talk about strings, about count, about various methods and these sorts of things, but that might have to wait until a little bit further down the road once things slow down a little bit again, because we're getting to that point where the semester is about to start and things are getting a little bit out of hand already. So why don't we go back into our folder and take a look at what we finished up with last time? Because we're starting to make more and more complex scripts that will, I don't know how the best way to describe this. I will say that it'll get us to where we want to be. I guess that's a reasonable enough thing to say. I was going to try to say something different because I don't want to sound like a broken record. But, it is what it is. So last time we were talking about count words. And I'm going to go ahead and open this up. And we can kind of review what was going on here. So all we were doing is we are loading in the Adventures of Sherlock Holmes from the English folder. We're reading in that file into a string, and we're calling it text. We are splitting along the spaces. We are getting the unique words. And then we're going to keep track of the most common word, and we need to also keep track of how often that occurs. We iterate through every unique word in the text, and as long as that's not a blank word, we go ahead and we count how often it occurs. We check its frequency. If it's the most common we've ever seen before, we go ahead and save it as a list. If we find another word that occurs an equal number of times, we go ahead and we append a word, and then we keep going from there. But I'd like to introduce a few refinements to this that will hopefully make this a little bit better, because in a lot of cases, we don't simply want the most common word, because in general, we can predict that anyway. We can, from a linguistics perspective, predict that the most frequent word in any document in English is most likely going to be the, right? And okay, sure, that I guess is useful. It's nice to confirm that we're looking at, in fact, a natural language document. And in fact, forensic linguists, when they work with documents, will often track how often words occur to try to see, is this a natural language or is this not a natural language? I don't want to, for the medievalists out there, dive too much into some of the wild theories about things like the Voynich manuscript, but people thought, oh, this is probably natural language because of the word frequencies. Although I'm recalling a popular article that I read maybe 10 years ago about this, so apologies if I'm incorrect about that. But the point being is that the most common word, not super interesting to us. It might be slightly more useful to count all of the words in a document rather than just looking at the most frequent. Now, of course, we will see that certain words will always float to the top here, and we can think about doing certain types of filtering to maybe not be influenced so much by those really common words. So one thing that you'll often see in natural language processing is removing of stop words. Those are words that occur very frequently in a language but don't necessarily carry with them a whole lot of semantic meaning. Now, I generally don't like to get rid of stop words because they'll tell you a lot about genre. Often they're useful for trying to predict who an author might have been, and they don't really get in the way that much as long as you know what you're looking for. So if you're trying to look for keywords, of course, stop words are going to kind of get in the way of that, but there are ways of filtering those out even there without removing them from your analysis by doing something like TF-IDF, which is term frequency inverse document frequency, which is just one way of calculating which words occur unusually frequently in a subset of documents that you're looking at. Unfortunately, we're not going to have time to talk about TF-IDF, but it does come up in that textbook by Melanie Walsh that I mentioned on the first day. And I encourage you to go check that out if this is the sort of thing that really interests you. If you see yourself actually doing this, you'll definitely want to know about that. But that's a little more advanced than we're going to get right now. Right now, what I want to do is I just want to kind of push our script as it stands now to do something a little bit different. And I think it's probably going to be best to just start a completely new script and not try to edit this one, because I worry that editing this might end up just adding a little bit to the confusion. And in the process of this, I'm going to add a few small refinements that might increase the quality of our analysis. And we'll keep adding to those as we go along. So let me come over here. I'm going to start a new file. I'll save this one as countallwords.py. And then I'm simply going to, I'll just retype it. It's not that big of a deal. So let's count all of the words that occur in a document. So here, we're going to go ahead and we're going to open the English adventure. I think it's actually lowercase, Adventures of Sherlock Holmes.txt. We're going to read it, and we're going to set the encoding to UTF-8. And as rf, and then we'll say text equals rf.read, just like that. So this will open up our file, assuming that, of course, I have written this path correctly. I think it really shouldn't be a problem. The next thing we might want to do is we might want to edit this just ever so slightly. I'm not yet going to get into the fancy tokenizers. We will talk about those in a minute when we get to the natural language toolkit. But I might want to do something like make it lowercase. So I'm going to say text equals text.lower. And this .lower will just make everything lowercase, right? And so, for example, capital T, the, is going to be equal to lowercase t. It's a pretty simple thing that is often useful to do. And note here that I am making text lowercase, and then I am overwriting the old version of text with the new one. And I'm doing this because strings in Python are immutable. That is, you can't change them in place. You can change them and then save the new version, but you can't just change it in place. So now what we're going to do is we might also want to pull out the commas and the periods. We could also do other punctuation if we wanted to. So we can say text equals text dot replace, and we can replace the commas with nothing. We can also say text equals text dot replace periods with nothing. Now, of course, you're probably noting that I'm repeating myself. This 6 and 7 are essentially doing exactly the same thing, only with different inputs in this first place. So we might consider ways of simplifying this a little bit. One thing we can do in Python is we can string these together. So we could alternatively make it a one-liner. And we can say something like text equals text.lower dot replace. Oops, I need my parentheses. .lower dot replace with the comma and the dot replace with the period. So syntactically, this will execute just like this will. Okay? And in fact, it might be marginally faster, but we're not talking about something that would ever be noticeable to a human. One other way of refining this a little bit is to figure out a way to put this in a loop. Because let's say I want to also remove question marks. Maybe that's something I want to do. I also might want to replace exclamation points, like this. So what I've written here works just fine, but in fact, I could replace this with a loop. I could say something like punctuation. I think that's pretty close to how you spell that. Comma, period. I think make that a question mark. Question mark and exclamation point. Okay? So what I could do here is I could simply say for punctuation, let's just say for punc in punctuation, text equals text dot replace punc with nothing. Okay? And so now I have just these 3 lines of code, and if I want to add another punctuation mark, let's say an apostrophe, I can go ahead and add it here with no trouble at all. Now, of course, apostrophes, really I don't want to be doing this so much because I'm in the end going to be using a fancier tokenization method that accounts for these punctuation marks. But for the moment, we can go ahead and replace them before we do our little script here. So here is kind of a functional way we will use loops to clean a text up a little bit. Excuse me. Okay. So, and here, if I wanted to be even more explicit, I could rename this for punctuation marks. For punctuation marks. And I could call this punctuation mark. This is kind of a nice verbose way of explaining, hey, here's what I'm doing. And anybody who looks at this code, who comes in later, should have a good sense of what I'm doing here. I wouldn't expect this to be super confusing, but of course you never really know. And here I might say this is make the text lowercase. Okay? So that is now our cleaned up text. And now let's go ahead and make our words list. And this is just going to be text.split space. Okay, we will get to fancier tokenization, don't worry. But I'm just going to split on the spaces. I'm going to go ahead and make unique words. And this is just going to be the set of words. And we talked about this last time. And now, here's where our code actually is going to be way simpler than it was when we talked about it last time. We don't need a list. We don't need to replace it. We don't need to keep track of a Sentinel variable. Instead, let's create a dictionary to hold our information. So create a dictionary to save word frequencies. And I'm simply going to call it word frequencies. And this will equal an empty dictionary, which I create with these curly brackets. Alternatively, I could just say dict with parentheses here. Functionally the same. It's just a little bit faster to type curly brackets. And note what happened there. When I did this, VS Code actually closed my curly brackets for me. But I have a habit of typing it out anyway. And if you do it too quickly, sometimes you end up with an extra curly bracket. So just keep an eye out for that. And now all I need to do is I simply need to say for word in word frequencies. And I have still misspelled for. There we go. For word in word frequencies, I simply need to get the word count. My hands are still in the wrong place. Word count equal words dot count word. And then I can put this into my dictionary to save the information. So I'll say word frequencies using the word as the key equal word count. Okay? Now, of course, I could combine this into one line. Actually here, sorry, this should not be word frequencies. This should be unique words. Apologies about that. Unique words. Because what I want to iterate through is each individual word in the text. And so then once I've done that, I can print out my dictionary. I can say print word frequencies, just like this. And then it will tell me what those frequencies are. Okay? So essentially, in a fair number fewer lines, we have accomplished a fancier goal. Let's just say that. So now what I can do is I'll go ahead and run this. And so just as, of course, reminder of how I get back to here, I'm going to change directories into my desktop and into my from 0 to n folder. And of course, I can check using dir or ls on a Mac. And we can see that I have my new file called count all words right here. So then I can run it by typing python countallwords.py. And so it'll run and it'll calculate all of this information for the Adventures of Sherlock Holmes. And then it will print out this dictionary of word counts. Now, this might take a moment because this is not going to be the fastest way of doing this, but it'll give us our answer. And so here we can see, here we can see that we have our list. So for example, we have caress, you, forgery, reason. But here we can actually see a problem with this, of course. We have all of these new line characters, right? The /n they're characters that you don't see, but that is how your text processor knows to move to the next line. but because we're processing it in Python, that actually gets thrown out the window. So what I might do is I might include other things to delete here. So in fact, I'm going to change punctuation marks to things to delete. And here, I'll say thing to delete without the S in things to delete. And so here, I'll just replace that. And now, I'll just put in the new line character. And here, I might also want to add quotation marks. So I'll go ahead and add in that. And note that in order to put a double quotation inside double quotations, I need this backslash. OK? And then what I might want to do is actually skip the empty character. So if word does not equal this. So if it doesn't equal an empty string, we'll go ahead and do that. OK? So now we're kind of cleaning this up a little bit further, where we are getting rid of new lines, we're getting rid of quotation marks, and we can run this again and see what it looks like. So I'll go down here. Apologies for that. OK, I will run count all words again, and it will be a little bit more refined. And in fact, I shouldn't have replaced the new line character with nothing. I should actually replace it with a space, because technically it is a space. Yes, Pinholga, yeah, that is precisely what's going to happen, which you'll hear me say in a moment. I guess you've already heard me say it. So in this particular case, we don't want, and you can see here, examine the serpent it. This is not what we want to happen. So here, we can just add this up here rather than adding it to our loop. I'll get rid of it here. And then I'll just say text equals text replace /n with a space. And so replace new line with a space. And so now, again, this is actually the process of building code for research. Is often you're going to need to do it in this sort of iterative manner, where you realize there's a small improvement I can make. Let's go ahead and stick it in. And so this is starting to look much better. But of course, we can see that it still has quotation marks. And the reason for that is these are known as smart quotation marks, and they're curved a little bit, and they're considered a different character than the original, than the straight quotation marks that I am replacing in. Yeah, Thomas, that is precisely it. So now, here in my things to delete loop, I'm going to add those curly quotation marks. And let's go ahead and make sure I'm grabbing both of them. Just like that. And then there's also a curly apostrophe that I might want to delete. Now, of course, this won't deal with compound words at all. And the Natural Language Toolkit is actually going to handle most of this for us. But regardless, I think it is still good practice. And we'll just leave it at that for the moment. And just know that you can keep going and keep refining really almost forever. There's always something you can do to make your analysis just a little bit better. So this will run for a second. And now we can see that it looks quite a bit better. There are, of course, some compound words with dashes in them. But, dishonorable, donors, this is starting to look pretty good. So you cannot copy the curly symbols on your prompt. That I'm actually not precisely sure. So depending on your computer, sometimes if you highlight it and right-click it, or if you're on a Mac, control-click it, that will copy it for you. On mine, Control-C works to copy those. Otherwise, there are online keyboards that kind of show you where these things are. One option could simply be to Google curly quote, and then it will actually return it. And this should be the same, for example. Oh, thanks in the chat for sharing that. That's great. Okay. So this gets all of the frequencies. And so if I run this in interactive mode, if I use a -i, it'll go ahead and run. It'll print this out, but it'll drop me into my interactive interpreter. And then I can start to look up certain words. So for example, maybe I'm curious about how often the, let's say, word frequencies, how often Holmes appears in the text. And we can see that Holmes appears 438 times. So that, might be a pretty useful thing. We can also look up things like Watson. He appears 81 times. We might also be interested in crime. That occurs 32 times. So you can start to query this, and this works really, really well. But there are other things you might want to do. You might want to get the top 10 words in the document. And we can do that with a relatively simple change. And that is by sorting this word frequency dictionary that we have now created. So what I'll do is I'm going to quit this. I'll clear this, and we'll go back to the code. And what I want to do is I'm going to save this as, and I'll say count all words sorted. And we'll save that. And now we're going to add a little bit onto this. So instead of printing this, I'm not printing the word frequencies. Instead, I am going to go into the dictionary, and essentially return a list. What am I trying to say here? I'm basically going to create a list of word frequencies by how often they occur in this text. Okay? And so what I can do is I can use the sorted function to do this. So sorted, just like this, and I'm going to save this as a variable. And so I want to say sorted words equals sorted, and then I'm going to give it word frequencies. Now, because this is a dictionary, I actually need to tell it what I want to sort it on. And I actually want to sort it on the internal values. So for example, I want to be sure that, Holmes comes before Watson because Holmes occurs many more times. So here I can give it a key. And one of the nice things about recent versions of Python is I can say word frequencies dot get. What this dot get does is it goes in and grabs the values for each key. And then if I print this, print sorted words, we can see what the results look like. But we'll actually see this isn't precisely what we want. I'm not going to do the interactive command here. This will run, and it will give me back the words in order, but it'll actually give me the rarest words first. Okay? I might have printed the incorrect thing here. Let me see. Oh, I'm running the wrong script. That's why. I should be running count all words sorted, like that. And so once this runs, it will give me the words, but they'll be from smallest to largest. And in fact, what I really probably want is from largest to smallest. So here we can see that at the very end of the list is the and I of 2. So this is actually giving me a list of the words in the order in which they occur in terms of their frequencies. What I might actually want here is I might want to get them in reverse order. And to do that, I'm going to add a keyword here, and I'm just going to say reverse equals true. And so the first words in this list are now going to be the most common words. And then if I just print the first 10 items, this will give me the 10 most frequent words in my document. And we'll see that here in a moment. And we can see that the 10 most common words are the and I of to a, in, that, it, you. So we're getting out of this a list of the keys in the order in which they occur in terms of their total frequency in our document. Now, this might be useful. One thing we can do is we can actually turn this into a little spreadsheet that contains our word frequencies from top to bottom. Okay? Now, there are libraries in Python that will do this for you. There is the CSV library, and I do recommend becoming familiar with that, but I'll show you how to do it kind of just with pure writing a basic text output. Okay? So, and again, there are many, many ways we can approach this, but what I'll do here is I'll say with open word count results. And I'm going to call this a CSV, that is a comma separated value file. I am going to open this in with the write flag, the encoding equals UTF-8 as WF. So we're opening this as a write file. And then I am simply going to write this information to this file. And so what I can do, there are a lot of fancier ways to do this, but one thing I might consider doing is I'm just going to write an F string, which we talked a little bit about last time. And actually, we'll have to hold off on that just for a second. I need to go through the sorted words. So for sorted word, or here I'll just say for word in sorted words, then inside of this loop, I am going to write to this file, and I am going to write the word, comma, word frequencies, and inside square brackets, word. Now, because this is an integer, I might need to tell it to string, but it might actually make that assumption for me. We're going to give this a shot and see what happens. Now, there is a problem here. And in fact, I want a new line character to make sure that all of my results appear on a different new line. So if I run this, then it will go through the script, and it should output the results to a new file that I'm calling wordcounts.csv, or whatever it is that I happen to call it. And so now, in this folder, we can see wordCountResults.csv, and let me zoom in a little bit so you can see here. I have my wordCountResults.csv, and you can see because I have used the .csv file extension, it assumes that I want to open this in Excel. I'm going to go ahead and open this with VS Code, just because that's what we're working on or working with. Let's see here. Visual Studio Code, I'll open this. And now we can see all of our word counts. And so you can see, I'll just go back to my desktop here. You can see the 5782 and 3051 was 1408. And you have all of this information, and you could open it in Microsoft Excel and make yourself a little graph, although we will be making some graphs probably, well, if not today, then tomorrow with these sorts of things. And so this becomes a nice handy way of running your analysis pretty quickly. Okay, well, sure, that's fine, but just looking at word counts in a single document, you can use all sorts of tools to do precisely this sort of thing. One thing I might want to do is, instead of just looking at the word counts in the Adventures of Sherlock Holmes, I might want to look at the word counts in every file in this English folder. Okay? And so what I'm going to do is that. And I'm going to jump the gun on one concept here that I was going to talk about in a few moments, but I think this is important enough to go ahead and introduce right here. I'm going to save this as a new file, and I'm going to say count all words sorted multiple files. Okay? So now, instead of just looking at this single file, what I want to do is I want to go through every file and check these same numbers for that file. So what I'm going to do now is I'm going to introduce one new concept, and that is of external libraries. So Python has a lot of default libraries that come with it that are essentially collections of code that extend the functionality of base Python. They do this because as more and more people contribute code to Python, you don't want every single function immediately available, because this will essentially pollute your namespace. And what I mean by that is, what happens if I want to write a function called text, but that already exists in Python? Well, that just means that Python's going to get really confused and it's not sure precisely what to do. So instead, what we do is we load in external libraries, okay? And there are a bunch that come with base Python, and Anaconda adds a whole bunch of others. But the one I'm going to use now is in the base Python distribution. So if you just go on to python.org and download Python 3, you will have access to this. And that is the OS library. To import a library so you can use it, you use the keyword import. Okay? So I'm going to import the OS library. And as you might expect, OS is a library that lets me interact with my operating system. Okay, so it's going to give me all sorts of functionality in kind of opening up directories and walking through them and writing out file paths and these sorts of things. And I'm going to use this to go through every file in this English folder. Okay, so I'm going to go ahead and just comment out everything down here, and we'll uncomment it here in a moment. But I want to show you this. There is a relatively canonical way of iterating through multiple files. And it looks like this. And it's going to be a little bit odd, but I promise you it's not that strange. So let's iterate through every file in a directory. Okay? To do this, I'm going to say for root dirs files in os.walk English. Okay? And then I need a colon because this is a code block, and I need to be indented out. And so what I'm going to do is I'm going to print root, I'll print dirs, and I'll print files. So we can see what each of these items are. So essentially what os.walk does is it goes into our directory, and in this case English, and it returns out from it information. It returns out the root of all of the files, it returns all of the subdirectories, and it returns all of the files in all of the folders in this folder. Okay? So when I run this, I called this Python count all words. Count all words sorted multiple files. Okay. Now, of course, my file names are starting to become a little bit unwieldy, but you know that's fine for a tutorial. I think that's a reasonable price to pay. So when I run this, it's going to give me English, that is the root directory. This is an empty list because I have no subdirectories in this folder. And so really, I think in all of the years that I've been doing this, I have never used this directory variable. It just doesn't tend to come up that often. And then I have a list with all of the file names of the files in the English folder. And if we look at this, in English, we see Adventures of Sherlock Holmes, Memoirs of Sherlock Holmes, and The Return of Sherlock Holmes. So that's great. That we have our information. Now what I want to do is I want to actually perform the same process that I did down here on my single file on all of these files. To do that, all I need to do is I need to iterate through each of the file names in that file list. So here I'm going to say for fname in files. I'm doing this because file is actually a reserved word in Python. I don't want to do that. So I'm going to say just for, I can say for file name. That would be fine as well. And then what I'm going to do is I am going to open up that file. And so here I'll use my context manager again, and I'll say with open. And here, if I just say file name, and I add, I'm going to read it. My encoding is UTF-8 as RF, and I say text equals rf.read. This isn't going to work because this will give me an error because the value of file name, and why don't I just read this, run this? So I'll print file name so you can see what it is. And if I run this, it does print out all of the file names, but it actually runs into a problem because it doesn't find the files, right? And actually you'll see that it does find the Adventures of Sherlock Holmes because in this directory I have the Adventures of Sherlock Holmes. So I'll just delete that, get rid of it. So the reason behind this is that I also need to tell it what folder it's in. So notice here I have English/Adventures of Sherlock Holmes. Here I need to add that. So I need to say, I need to give it the full file path. And in this case, it's English plus file name, or rather English/ plus file name. But of course, this looks really, really bad. I don't want to do this because, you know, what if my operating system really does make me use those backslashes? I don't really like that much. Fortunately, the OS library comes with a handy function that will put together different parts of a file path. So what I'm going to say is I'm going to make a new variable called file path. This will equal os.path.join, and then I'll give it root, comma, file name. Okay? And then I'll put file path here instead. And so why don't I print out the file path so you can see what that looks like. And so if I run this, it gives me English/Adventures of Sherlock Holmes, English/Memoirs, and English/Return. Okay? And the nice thing about this is if you run this very same code on a Mac, it will have the /s instead. And so it's a really handy way of making sure that your code remains operation or OS independent. Okay? It doesn't matter what operating system you have. Of course, I could just directly put this here, but sometimes it's nice to be a little more verbose and make it very, very clear what you're trying to do. Okay, so that actually gets us up to this point here on line 11 where we've read in our text. Now, I'm just going to delete this, and I want to run the rest of the code for each file individually. So to do that, all I need to do is I'm going to go ahead and uncomment this. And while all of this is highlighted, I'm going to hit Tab, Tab, and now this is going to run inside this for loop. So now what's going to happen is all of this code runs for each file. So for file name and files, we'll get the root, the file name, we'll open it and save it to this variable text. We'll make it lowercase. We'll replace our new line characters with spaces. We'll delete all of these things. We'll split it. We'll calculate our word frequencies, and then we'll write this to file. Now, the eagle-eyed among you might notice that we're going to have a problem right here. And that problem is that remember what I told you about opening things with a write flag? It will overwrite anything that that already exists with this file name, right? And we don't want that. Might want to add if file name ends with .txt. Not necessarily, because often we'll be working with JSON files, we'll be working with XML files or HTML files. And the reason I don't like to do that is because it kind of reduces this the universality of this. Although you have a very, very good point that often, because this isn't paying too much attention to what the file names are, if you have hidden files in there, or if you have like JPEGs or something, this will break. So in this particular instance, I'm kind of depending on everybody to make sure that your files in your folders are only the files that you actually want to analyze, okay? So sometimes what you can do is if you want to not read in any hidden files, is to say something along the lines of we could say if file name 0 does not equal a period with a colon, and then here I could tab all of this out. That would work. One other thing I could do is I could get slightly fancier and I could actually filter it out before I run through the loop. There is a way in Python of writing loops on single lines when they are lists. So I could actually say something along the lines of files equal file name for file name in files if file name 0 does not equal a period. Okay? This is going to come up when I show you how to filter out stop words, because this is a really quick way of writing a loop. And so here, this is simply saying for every file name in files, if that first character in the file name is a period, it's a hidden file, then it just says, you know, if this is true, don't save it. If it is true, save it, right? So it's a little bit, you know, I don't know, it's slightly complex, but note that this is the same as doing something like temp files is going to be an empty list for file name in files if file name 0 does not equal a period, temp files dot append file name, and then files equal temp files, right? So this code is functionally identical to this code, okay? Most of the time, as long as you're careful to not let hidden files show up in your analysis directory with your corpus, this isn't going to be necessary, but I'll leave it in there because it is a good thing to have. If you want to if you don't want to include anything that doesn't have a .txt at the end, you could do precisely what, and apologies, Mastoff, sometimes usernames are hard to pronounce, apologies about that. You could do precisely that. You could say file underscore name dot ends with .txt. And this should be if not that, okay? Apologies, I realize I'm introducing a new syntax that might be a little bit hard to absorb. But regardless, now we have something that should run through all of our files, but we should also think about how to address this word count results. One option is to just add our file name to this file name, so we're creating multiple files. So for example, we could use file name here, and here we would want to remove that .txt. If I make this an f string and I add these curly brackets and I put file name and then colon -4. So here this is basically just file name except the last 4 characters, which of course are .txt. If I do it this way, then I get an individual CSV for each file that I'm working with. Now I could also adjust this so it writes all of them to the same CSV and it just keeps track of which file it comes from. But for the sake of demonstration, let's go ahead and run this. And assuming I haven't made any typos, we'll go ahead and let it produce the 3 new CSVs that contain our word counts. And so here, let's kind of keep an eye on it. We should see this, as long as I don't get an error, come up with 3 new CSVs. Now here we go. Adventures of Sherlock Holmes has already been produced. So I'm going to go ahead and open this with Visual Studio Code so we can take a look at it. So this is the Adventures of Sherlock Holmes and all of those word counts. Then momentarily we should get Memoirs of Sherlock Holmes, which is down here now. And we can take a look at that as well with Visual Studio Code. And we can see that the numbers are actually a little bit different. Holmes only occurs 358 times in this particular document. If we don't want separate, files, that's also fine, but we would need to refine our approach a little bit. And this is the last innovation I'll introduce for this particular script, and then I want to move on to talk about dealing with errors and writing functions, and then we're going to get into the natural language toolkit. So another way of approaching this is to actually have a list that we append all of our information to, and then we're going to write that to file once we've looked at everything. Okay? And I'll show you how this works. So I'm going to create a new variable to save the results of my analysis before anything else runs. Excuse me. So I'm going to say results, and this is just going to be an empty list. Now, this could be a dictionary if I wanted it to, but a list is going to be relatively easy to deal with. And so down here, instead of writing this file, what I'm going to do is I am going to get rid of this. I'm going to make sure everything it has the right indentation level. So I need to tab that back out. And so what I want to do now is I want to go through every word in sorted words. And instead of writing, what I want to do is I am going to append to this results list. So I'm going to say results.append. I'll get rid of this right. And here I'm going to get rid of the new line, and I might as well add the file name, right? So here I'm going to add file name. And I could cut off the file extension. Okay? So here I'm going to have word, the number of times the word occurs, and the file in which this happens. Okay? And I'm appending this to my results list. So now what I want to do is I want to make sure that all of my code runs, and then I'm going to write to file. So if I tab all the way back out, my results list now should have all of the information. So now I'm going to say with open, I can say something like all file counts.csv. This is going to be write. Encoding again is UTF-8 as write file. And now I want to write this results list, but I can't directly write a list. I want to actually turn this list into a string, and I'm going to do that by joining it together with new lines. Okay? And so essentially, it's going to take a list of items that look like this: word, word frequency, file name, separated by commas. It's going to join them by new lines, and it's going to write to this new file called all file counts. If I save this and I run it, we should, once it has finished processing all of these things, give us the results that we're looking for. And instead of 3 different files, what it's going to have a single file with an extra column that specifies which document this came from. Now, admittedly, this isn't super sophisticated, and but we can now use Excel to analyze these numbers a little bit. We're going to actually do a little bit of analysis on them in Python tomorrow when we do our visualization discussion, but you could do Excel. And I know a lot of people are already familiar with that, and that makes it a good thing to use. Okay, so it finished running, which should mean we now have all file counts, which is great. And we'll open this with Excel. Actually, yeah, that's fine. Okay, so we've opened with Excel. We have the word, the number, and the file that it came from. And we should have this for each document that we have. Return of Sherlock Holmes, Adventures of Sherlock Holmes, and so on and so forth. We could get even slightly more sophisticated. Instead of duplicating all this information, we could have in column B the number from Adventures, in column C the number from Memoirs, and in column D the number from Return of Sherlock Holmes. But that actually might be a good exercise for you to kind of think about tonight, is how would I get this information in that format? So why don't we'll leave that one as an exercise for the viewer to figure out. It is pretty simple. You have all the tools you need to know now, but yeah, I'll leave that to you. So you've probably noticed up to this point that we've only been dealing with English files. What happens if we wanted to work with French? Well, a lot of the same assumptions kind of hold true for French. If I just change this to the French directory, it will run on all of the files in the French directory. And, French at least has spaces between its words. And so if I run this, it should still work, right? I should still get kind of a general sense of the word counts in Proust's Swann's Way. That being said, it's not going to be as precise because French tends to have more contractions in its words. And one thing we haven't really dealt with is, do we want to consider different tenses of the same word as the same or different words? And so this is where we're going to need to bring in other people's codes, because we ourselves don't really want to have to write Python that deals with the rules of conjugation in English or the rules of conjugation in French. Other people have done that for us. So this is finished running. So let's jump over here really quickly and take a look at it just to double check to make sure that this has worked. I don't have any reason to suspect that it didn't. And duh is indeed, and I think this came up last time or the time before, the most common word. So, this gives us a relatively clear view of what's going on. Of course, as we go deeper here, we'll find there are mistakes as less frequent terms kind of show up. But that works. But what happens if I try to do this instead of English or French with Chinese? If I change this to Chinese, this is actually going to completely it shouldn't give me an error. It should still run, but it's not going to give us good results. So let's take a look now at this all file counts. Yeah. So if we look at all file counts, instead of getting words, it's really just, it gives us essentially sentences. So the assumptions don't apply, because we can actually see in this particular instant that the words do not have spaces between them, right? And in this particular sentence, it might be something like this, right? In this particular case, somebody named Songjin has gotten onto like the bank of a river or something and is collecting firewood or something along those lines, right? Of course, Python doesn't have any idea, right? It doesn't know how to break this Chinese sentence into these words. So we're going to need something more sophisticated to deal with that. And we'll get to that. Apologies, there's a truck outside my window. I don't know if you can hear that. But I want to kind of do a little bit of kind of bookkeeping before we get there, because one thing you'll encounter as you start to write files like this that get more and more complex is errors. The errors that you run into are going to be frustrating at first. And so it's good to know at least a little bit about how to fix them when you run into them and how you can try to prevent them in the first place. Now, I will say that the errors that deliver errors at the terminal are so much better than the errors that just simply happen quietly, and there are plenty of those. But I'm going to show you those in a minute. I think I'll take a quick 3-minute break and grab myself a glass of water, and then we'll resume in a couple of moments. So, and please put any questions you have in the chat, and I'll see what I can do to address them. So I'll be right back. All right, I'm back, and let's go ahead and get back to it. Yeah, terminal giving syntax errors. I would bet that's because you typed in Python by itself. If you have 3 greater than signs on the left-hand side of your terminal, that means you're actually in Python and you're not running your Python code. You're actually trying to type Python code into your terminal. So then if you type in, so for example, let me clear this off. If I type Python by itself, you see here these 3 greater than signs. And if I tried to say Python, my code.py, it'll give me a syntax error that looks like this. My guess is this is what you're seeing. To fix this, type quit, and it'll drop you out back to your actual terminal. So hopefully that'll fix your problem. But we are going to be talking about errors now. And so if it's actually an error in your code, then that's what we're going to talk about. So I'm going to open a new file here. I'll save this, and I'm just going to call this something like errortest.py. Let's kind of talk about what happens when we have a syntax error in our code. So let's imagine that I want to write a for loop, and I can make this a little bit bigger here. And so there are many kinds of errors that we can run into in Python. One of the easiest, fortunately, to fix tends to be syntax errors. So for example, if I went to say for I in range 20, print I, right? This might look okay, but VS Code actually tries very hard to fix our syntax errors for us. And in this particular case, we can see that there is this little red line, and if I put my mouse over it, it says invalid syntax, unknown line 2. If I try to run this, I say Python error test.py, I'll get an error message, and it'll tell me what file this happened in, what line it happened on, and it will try to figure out where this actually happened. So for I in range 20, it thinks there's something right about here that's wrong. Now, this little caret can often be completely in the wrong place in your code, and this can be a little bit frustrating to deal with. In this particular case, it actually highlights it precisely. It's telling me invalid syntax. That means something is wrong with the code itself, right? Not the logic of the code, but the way the code is written is not valid Python. To fix this, of course, I need a colon, because that's how I indicate that I am starting a code block, and the thing on the next line should actually be tabbed out. Okay? Similarly, if I don't have that tab, this will also give me an error. And in this particular case, it actually knows what the problem is. In this case, expected an indent block, but I didn't indent, so it's going to try to highlight that for me. And of course, it tells me right at print I, there's a problem. So that's pretty good. So if I tab it again, that will, oops, sorry about that, and save it, that fixes those errors. Another example of a syntax error is when you forget to close a string. Let's say I have a variable that I'm going to call A and hello, and let's just imagine that VS Code doesn't provide me with that closing quotation mark. Keep writing code. I'll say B hello times 2, and C equals 5. Okay? And let's say I have actually 2 errors in my code. What's going to happen when I run this code is that the Python interpreter, as it's trying to essentially figure out what it needs to do, it's going to break when it gets to this error on line 5. Notice that Python doesn't actually highlight, or VS Code doesn't highlight this mistake. It only highlights this one. And that's because the interpreter basically gives up when it gets to right there. So if I run this, it tells me I have a syntax error, and in this case, it's EOL while scanning string literal. What this means is, hey, you got to the end of the line, but you never closed your quote. Okay? And of course, to fix this, if I close it, that fixes that. But then when I run it again, it will get me down to line 8, and it will find this next error. And it says end of line while scanning string literal. And of course, now if I run this, the code will run, just with no problems at all. So now it goes ahead and runs that for loop that I have at the beginning of the code right here. I don't need to see that, so I'm just going to comment that out. And so syntax errors tend to be relatively easy to fix. One syntax error that is harder to fix is this. Okay. So for example, I just put a colon here, but this is actually a Chinese colon. And so this looks visibly, if I didn't have this error highlighting on, I would have no idea where the syntax error is here. So if I run my code, oh hey, actually, my terminal here isn't displaying Chinese, so it's actually easy to identify. Sometimes it's not when it actually can display these properly. Sorry about that. Yeah, so let's go ahead and take a look at our code again. Let me see. Okay, so these errors are usually pretty easy to deal with because they're syntax errors, and the interpreter is going to have a really good idea of what the issue is. So I'm going to change this back to English and do it that way. Okay. What happens, however, if I have an error that is not a syntax level error? So let's imagine I have a list, and I'm going to call this my list, and I have a list 1, 2, 3, 4, 5, and 6. What happens if I try to print from my list the item that exists at index 100? Now note that my interpreter doesn't actually, my list equals, sorry. So it saw that syntax error, but now I have another issue where I'm trying to look for an item at index 100. In this case, Python actually doesn't know that there is no item at index 100 before I run the code. So this is what's known as a runtime error. My code is going to compile properly. Again, Python is not a compiled language, but it's going to put it together and it's going to say, oh, the syntax is okay, let's go ahead and run. And in this particular case, when I try to run it, it'll run until it hits this error here. And it's going to tell me on line 13, when I try to print this, list index out of range. Okay, so now I know, for whatever reason, I'm trying to look up a number I'm trying to look up something at an index that just, it doesn't exist. And you'll notice here, when I had my syntax errors, this for loop wasn't running. In this particular case, that for loop will run because that code executes. It doesn't realize that there is something wrong until it actually gets to this line of code and executes it. Okay? So sometimes this can lead to complex to diagnose issues, particularly if you are creating a list as you're running your code. Okay. There are similar errors you can get with dictionaries. So if I have a dictionary that I'll call my dict, this will equal curly brackets, and I'll just say Paul 10 and Shannon 11. What happens if I try to look up somebody who's not in this dictionary? Well, if I print my dict and I do something like Roger and I run this code, we can see that I get a key error. And in this case, it's just going to be telling me that, hey, this key doesn't exist in this dictionary. Python has all sorts of errors that are used for the sorts of things you're going to run into. And you can, in fact, define errors for yourself. We're not going to talk about that for ourselves, but just know that that is something you can do. Of course, a classic one is, what does Python do with this? What does Python say when you try to divide 5 by 0? Well, it basically just says that's a 0 division error. Oh, does new Python actually not give you an error? That would be unfortunate. Oh, no, I didn't save it. There we go. 0 division error, division by 0. So Python will not let you do something like that. So just be aware. So how do we deal with errors? We can try our best to make sure that our code, we're never doing anything with our code that doesn't work. But of course, in practice, that is not how it works. So for example, I might actually not know beforehand what the contents of this dictionary are. So I can actually use what are known as try and except blocks to deal with this. So for example, I could say try colon my dict Roger. And then I could say except my print person not in dictionary, right? So when I run this, we can see that it actually prints person not in dictionary. Now, this is going to be kind of bad practice because note that if I have Paul here, I know that's in my dictionary, but I forget to close that. Well, actually, it might not let this happen. Yeah, it doesn't let the syntax error through. But for example, what's a good... Sometimes you can have errors on these lines that will, the code will trip the try and except function, but they're not the errors you're looking for. So you can actually specify only catch it if it's a key error, right? So if I say except key error, print person not in dictionary. So if I run this, it says person not in dictionary. Oh, I have an example. But what if I also try inside of this to get the number from my list 100? So remember, my list 100 doesn't exist. But if I run this, it'll tell me person not in dictionary. Well, that's not really the issue here. The issue is actually that there's a syntax or there's an index error there. So if I say except key error, it's not going to catch that index error. And so when I run this, it'll still catch that error. So if you use try and except, which, you know, it has its place, always specify what kind of error you're trying to catch. Often it's better practice to check, hey, is this in my dictionary before you try to get any information out of it? But, you know, that is something you can do. Okay. So we're going to talk about the last thing I want to talk about before I talk about the natural language toolkit. And this is creating our own functions. Okay? This is another syntax thing that is going to help us write simpler code. So in many cases, I'll call this function fun.py. In many cases, we find ourselves doing the same thing again and again in our code. And of course, one option is to do it inside of a loop. That certainly works. But in other cases, it makes sense to take the thing that we're doing and put it into its own function. So for example, if I am trying to get the standard deviation of a list, and I'm not using some external library, I might want to define a function that does that for me, so every time I try to do that, I don't need to actually work out the math. So I'll show you how this works. Functions are defined in Python using the def keyword. So I'm going to say def Paul's function with parentheses and a colon, okay? So this lets me define a function. I'm naming it something. I can name it whatever I want. I need two parentheses, and I need a colon, and then inside the function is going to be the code that will execute anytime I run this function. So I might say print, hello, this is Paul's function. And then, so if I save this and I run it, Python function fun, note that nothing happens. The code says print this, but when I run it, nothing happens because I am not calling my function. So to call this function, all I need to do is say Paul's function, parentheses. And when I run the code, it executes that function. I could, of course, then run it 4 times, and it will execute 4 times. So that's cool. I could put it in a loop. I could say for I in range 4, and then I could put tab that out and delete these, and it will still run 4 times. So what this will let me do is this will let me kind of cordon off parts of my code that I'm going to want to reuse in different places. Now, of course, this sort of function is not super useful. It doesn't take any input, and it always outputs the same thing. So I can make this a little more sophisticated if I say define whose function, and then parentheses colon, but inside the parentheses, I give it a variable name. And I'm just going to call this name, but this is a variable that I am creating that could be called, you know, anything that I want it to be. It could be hey there, okay? But I'm going to call it name. And then inside of this, I'm going to say print with an F string, hi, and inside curly brackets, name, nice function, just like this. And so now I can actually execute it, whose function, and I can, inside this, put Paul, whose function, Javier. And so it will execute in the first case. It will take name, it will insert it in here, and it'll go ahead and run that code. And it'll do it for both Paul and Javier. So when I run this, hi Paul, nice function. Hi Javier, nice function. Okay? So this is the first step we might take to make this better. Okay? Now, I am not limited in how many parameters I can give to my function. And so whatever comes inside these parentheses, this is known as a parameter. So for example, I might create a new function called greeting, and I'll give it, you know, your name and my name. And in this case, I might say print hi your name, and I need to make sure that this is an F string. My name is my name. Okay? And so to run this, I would simply say greeting, and here I'll give it 2 strings, Javier and Paul. And when I run this, now it will say, hi Javier, my name is Paul. Okay? Hopefully this is relatively straightforward. And so then if I want to greet somebody else, and I could say something like greeting Yajun and Greg. Okay? And so, hi Yajun, my name is Greg. You know, for example, we can do these sorts of things. It makes reusing code very, very simple and relatively elegant. In other cases, we can, again, make our greetings even better than this. So let's say we want to define let's just call this interaction. And here, I'm going to give it your name, my name, and maybe I want to give it an interaction type. Excuse me. Interaction type. Okay? And now I can say if type, interaction type is a greeting, then what I can do is I can just copy this. But if it is a elif interaction type is a parting, I can say print something like goodbye, your name. Something like, I don't know, my name. I don't know, when you depart, you don't usually say my name out. So for example, you could do this, right? And then all I would need to do to use this is to say interaction, your name, and here I'll say Javier, I'll say Paul, and I will say parting. And when I run this, goodbye Javier, Paul out. Okay? So we can give it as many variables or parameters as we want, but one thing we might want to do is we might actually want to make one of these variables have a default value. So we could, in our function definition, say equals greeting. So what will happen is if I don't give it that third parameter, it will just assume that it's greeting. And so when I run this, it'll run the greeting code instead. Okay? And so then I could alternatively say interaction type equals parting. And now it'll run the parting code. Okay? I could also just leave out this because it does understand the order in which you put them in. But one thing that you need to know is that these keyword parameters must come after your named parameters. Okay, the ones without the equal sign always come before the ones with the equal sign. So just keep that in mind because it is an important thing to know about. The last thing I want to say about functions before we get into the natural language toolkit, and I realized I only spent like 10 minutes on this because I would spend most of a day on this in my regular class, but hopefully this will help you build these sorts of things. The last thing I want to talk about is returning things out of our functions. So you'll note that all of these functions do something, but if I want to save the results of these things, if I want to say something like results equals interaction, and I print result, it's actually just going to give me result. It's actually going to tell me, hey, none type. It's going to say none, right? And that's because I'm not returning anything out of the function. So let's, I'll show you what I mean. So let's say I want to write a function that adds two numbers. I'll call it add, and I'll say num1, num2. And this will just add these two numbers together. Let's say I'll say result equals num1 plus num2. Now, of course, in practice, you're never going to write a function that is this basic, but hey, here we are. And then I want to return result. So now I can actually save that to a variable. So I'll say res equals add 15 and 20, right? And so this should give me 35 if I print res. Print res. You can see there it printed 35. So that's relatively simple. And of course, I could, if I want here, instead of returning results on the next line, I could simply return num1 plus num2. So if the code that you're trying to write can be done in a single line, you can just immediately return it. Okay? And so those are the very, very basic things that you, I think, need to know about writing functions. Now, there are even fancier things we can do in these functions. For example, you can call the function you just wrote inside the function if it's recursive in a certain way. You can make them do very, very complex things. You can call other functions inside your functions. They're very, very useful, and they will help you simplify your code. And the nice thing about this is that if I discover actually I have a bug in my adding code, but I'm using this add function a whole bunch of times elsewhere in my code, all I need to do is fix it in my function. I don't need to go back to the rest of my code to make sure that I haven't messed something up elsewhere. Okay, so let's move on and spend the last 30 minutes talking about libraries and specifically the natural language toolkit. I'm excited because I was worried we weren't going to get here. You never know with these sorts of these sorts of workshops where if you've never done them before, and I've never streamed something like this before, you never know how far you're going to get. But this is good. I'm happy about this. So I'm going to show you I don't know what I'll call this, library fun.py. I'm not going to run this particular piece of code because all it's going to do is I'm going to introduce you to a number of useful libraries that have extra code that help you do useful things, right? So I'll say some good libraries. So as I mentioned earlier, when I imported the OS library, in order to import a library, we use the import keyword, okay? And so once I import something, let's say I import math, I can then use any code that's associated with that particular library. So for example, with math, I know I said I wasn't going to run this, but I think a good example in math is the do they have absolute value? I think it does. Or let's just say cosine. If I want to get the cosine of a value, I can use the cosine function. And when you, one of the nice things about VS Code is it will actually suggest to you all of the different things you can do. So you can get exponents, you can do factorials, you can check if something is not a number. You can get the logs, power, sine, cosine, tangent. You can convert something to radians from degrees. There's all sorts of useful stuff in the math library. And there might even be, I really thought there was an absolute value in math. For example, it has pi. So I could say math.pi, and this will actually give me 3.14159, so on and so forth, right? So math is a pretty useful library. You know what? I'm not actually going to run it. So that's fine. Other useful libraries, there is the random library, and this has various pseudo-random number generator functionalities. So for example, I could, with the random library, get a random integer between 0 and 25, right? And that has its uses in certain cases. I think random.random will give you a number, it'll give you a float between 0 and 1 that is randomly generated or pseudo-randomly generated. There's a lot of handy things. You can get a random range, a lot of useful things in the random library. One thing to note is as you're importing libraries, you can import multiple libraries on the same line. So you can say import math, comma, random. We could import RE, which is the regular expression library. A regular expression is a way of matching patterns, and it can be very handy for breaking longer texts apart into, say, chapters or short stories. And we will probably get into that when we run our analysis tomorrow. And so I'll show you I don't want to get into regular expressions because they really deserve a week-long workshop all on their own because they are incredibly useful and powerful, but syntactically they can get a little bit confusing quite quickly. I do cover them in my class, and I think students leave the class thinking this is one of the most useful things I've learned how to do. But we can use them in Python with the RE library. I will say that the Python regular expression implementation is not as good as Perl's, which is kind of a shame, but it is what it is. We already talked about the OS library. This lets us interact with our operating system. JSON is a way of creating JSON objects. So if you're not familiar with it, this is JavaScript object notation, and it's a good way of kind of saving your results. If you ever work with APIs, you'll often want to use the JSON library, okay? And of course, you can keep adding things, Nltk, pandas, and so on and so forth, but often it's good just to start a new line for visibility's sake. All of these libraries here are part of the Python standard distribution. That is, you don't need Anaconda to have these by default. The next ones that I'm going to tell you about, you do need Python, or you do need Anaconda, or you need to install them separately. So one that we'll be using today is Nltk, or the Natural Language Toolkit. There's also something called the Cltk, which is the Classical Language Toolkit, which is, I think it's designed with a similar philosophy, and it's aimed at ancient languages. They were thinking about adding Chinese compatibility, or better Chinese compatibility with it, but haven't really had a good chance to do so. But it's a very cool library. I don't think I actually have it installed on this computer at the moment. But Patrick Burns and Kyle Johnson are the two primary developers on that, and they're very, very smart classicists. But anyway, so the Natural Language Toolkit, we're going to get into that in the last 15, 20 minutes we have today. But we also will be talking tomorrow about Matplotlib, and this is a visualization library. It will let us create graphs. Now, Matplotlib is a little bit old school. The mat in Matplotlib is MATLAB. It was designed to create graphs that look like MATLAB. And I guess I would ask the question, when was the last time you saw a graph produced in MATLAB? And I would bet it's been a long time. They do look a little bit dated at this point, but we'll talk about how to make them look a little nicer as well. And we'll also be using Seaborn, which is kind of built on top of MATLAB, and it just makes things look a little bit more modern. There are some really good data munging libraries and data analysis libraries called pandas. Pandas is an implementation of a data structure and philosophy that is meant to seem a little bit R-like, if you're familiar with R. We probably won't get too into pandas, sadly, but it is useful to know about. There's NumPy, which has lots of fast numbers processing capabilities. Those are the libraries I just kind of wanted to mention. One thing to know, though, is when you import a library, let's say you're importing pandas, you can alias those libraries. That is, you can give them different names. So the standard way to import pandas is not just import pandas, but import pandas as PD. And the reason is, the reason behind that is when you use items from pandas, so often you'd be using a data frame, it's kind of a pain to type out pandas every time. So if you have imported it as PD, you can just type PD. So pd.dataframe, for example. Another thing is you can import individual modules from larger libraries. So one piece of code that you will see again and again and again in data visualization is from Matplotlib, import pyplot. Okay? And this is a module inside this library. And you can also alias that. So you can say as PLT. Import pyplot as PLT. This is a very, very common thing, and it's kind of the standard way of importing that particular module. Okay? I could also do something like import matplotlib.pyplot as PLT. So these are kind of all functionally the same thing. Okay? So this is going to let us load in extra code that's going to let us do all sorts of useful things. Now, I generally don't recommend loading in things that you're not going to use, because really there's no reason to load in pandas into your namespace if you're not going to be using it. So only load in the libraries that you plan to use, and conventionally by style, import everything at the top of your script. This just helps people see what external code you're going to need to actually run this particular file. Okay, so that's a conventional thing. You can actually load them at any point as long as you do it before you use them. But it is a good idea to put them at the very top of your script. Okay? All right, so this brings us to the last 20 minutes, and I want to talk about the Natural Language Toolkit. Okay, this deserves a lot more time than 20 minutes, and we will come back to it tomorrow because it has better tokening functionality than we've had up to this point in this tutorial that I've been giving, because we've just been using white spaces, right? Next time we'll talk kind of philosophically about what's going on here. But let's jump into, and I'm going to call this nltk._demo.py. I'm going to save this. Note that I didn't call it Nltk, because if I did, when I try to import Nltk, the first place Python is going to look for Nltk is in the local folder. And if it sees a file called Nltk, it's just going to import that, and it's going to ignore the library. And we don't really want that to happen. So to use Nltk, what we need to do at the top of our file is to import it, Nltk, okay? Now, the next thing that you're going to need to do, and you only need to do this a single time, is to download the extra stuff that Nltk needs to do its fancier things. So the library itself kind of comes with a basic set of functionality, but in certain cases, you're going to want like lemmatizers and stemmers and named entity recognition functionality, and you're going to actually need to download those. So you need to call nltk.download with parentheses like this. Now, this doesn't work for everybody. I have had students have just like the worst trouble with this particular call. And there is a command line interface that you can use to do this as well that tends to be a little bit more robust. My hope is that is a problem of the past, and we're going to give this a shot. But I'm not going to run that code that I just wrote, and instead I'm going to do this. I'm going to type Python by itself, and I am now in my command line interface, okay, for Python. And I am going to import Nltk here and hit enter, and it will load in. And once I've done that, I will type nltk.download with parentheses and then hit enter. And it will execute this line of code, and it will open up a window that looks like this. Let me zoom in a little bit here. You can see that it has a number of different things you can install. So there are demo corpora. There's everything that's inside of the book. There's everything inside of the popular packages. And you can highlight these and double click them to download them. You can click the download button. You could do installed. I usually just do the popular ones, but you can kind of explore everything that Nltk has available. And there's a lot of really, really good stuff. There's C-SPAN inaugural address corpora, which would have been updated yesterday, I hope. There are annotated corpora. There's a Portuguese tree bank. The brown corpus is a pretty common natural language processing corpus to work with. So there's a lot of really, really good stuff that you can kind of play around with here. It also comes with various models. There are part-of-speech taggers for different languages. There's grammars for Basque. I think the snowball data helps you train lemmatizers or stemmers. There's all sorts of useful stuff here, okay? And then, of course, you could just download everything. I think everything's pretty big. It's a few gigabytes. I just tend to download popular. And for the sake of this particular workshop, that's all you'll need to do, okay? Once you're done, you can close this window. It will exit, and it'll say true, assuming no errors have happened. And then we're done. We actually never need to call nltk download again until you decided you didn't download everything that you actually wanted to download. Okay? And then we can actually start to do some cool stuff with this. So what I'm going to do, with only 15 minutes left, with my amazing time management skills, is I'm going to delete this nltk download line. Don't need to think about this again. What I want to do is I want to use this on one of my Sherlock Holmes texts kind of as a demonstration. I've been talking about tokenization quite a bit. How do I break these strings into individual words? Nltk has a few tokenizers that will help with this. And so it has ways to break things apart into sentences, and it has ways to break things apart into words. So what I'm going to do, just very, very quickly, is I am going to go ahead and I'm going to load in the Holmes text, and I'm just going to grab it from my countallwords.py. I'm just going to grab this here. Sorry. And let's close that. And actually, let's go back here to Nltk demo.py. Here we go. OK. And all I did was I just didn't want to have to type this again. Let me zoom out a little bit there. And I'm just loading in the Adventures of Sherlock Holmes. OK? Nothing more than that. I just want to have this as a demonstration of the natural language toolkit. So once I've done this, one thing I might want to do is I might actually want to cut out a little bit of text from the Sherlock Holmes file. If we take a look at this, if I go into the Adventures of Sherlock Holmes, I have all of this preamble from Project Gutenberg that I actually don't want in there, right? I don't really care that much that this comes from Project Gutenberg when it comes to doing my linguistic analysis. Now that it does matter, because often where you get a text will really influence your results if there are, formatting things in there that your program might pick up on. But I'm just going to grab the start of this Project Gutenberg ebook. This little phrase basically is attached to all Project Gutenberg ebooks. So if I don't want this, this kind of boilerplate up here, I can delete that. And so I'm going to do that really quickly, simply by going back over to my code here in my Nltk demo, and I'm going to say text equals text. And then remember, this is the number here is where I want to start, and the number here is where I want to stop, right? So what I can actually do is I can say text.find this string. So that will find *** space start of this Project Gutenberg book. Okay? And then I just want to basically start my text at this point. And I'm going to let it include start of this Project Gutenberg ebook. I could, of course, say, move to the next line, but I don't really need to do that. I'm also going to grab an endpoint. I'm going to cut it off. Text equals text. And then at the end, there's actually more boilerplate that ends something like, let's see here. Here we go. So there is a lot of this kind of boilerplate that says, hey, this is public domain. This is the license. I am just going to grab end of this Project Gutenberg ebook right here and come back over here, and I'll say after the colon, text.find end of this Project Gutenberg ebook. Excuse me. So this is kind of a quick and dirty way of getting rid of the boilerplate on either side of this text. Now, you'll want to be a little careful here because sometimes maybe there are capitalization issues. If it's not precisely this, and one of these numbers actually returns -1, you're going to run into some strange strange issues. So you're always going to want to make sure that your corpus is relatively clean. Okay, but in this case, I know this is in my file, so I'm going to go ahead and use that to truncate it a little bit. And now I'm going to start tokenizing it. So one thing I can do is I can tokenize into sentences. So for example, I can say sentences equal Nltk dot sent tokenize text. Okay, and I'll print sentences up to 10. Okay, so this will print the first 10 sentences. I need to make sure I have spelled this correctly. There we go. So I need to quit this. Okay, so I'm going to run Python Nltk demo.py, and it will load this text in. It will tokenize it, and then it will print the start of my my book. And you can see it doesn't handle these new lines particularly well. but it is roughly in sentences. So this will look a little bit better if I dig a little deeper into this. I can say 100, and I'll go to 210. Yeah, so you will still, in this case, get start of the Project Gutenberg ebook. But that's not that big of a deal because that's not going to influence our results, generally speaking. We could be, like I said, a little bit more precise about this, and maybe we'll talk a little bit about that next time, because often you want to avoid adding too much noise into your data set. But yeah, that is a good point. So here we can see putting his hands into his pockets, he stretched out his legs in front of the fire and laughed heartily in some minutes. Okay, so one thing we can see here is, of course, it doesn't handle new lines very well, and these Project Gutenberg ebooks are a little odd in that they have hard returns, in the midst of a bunch of sentences. So one thing I might want to do is I might want to actually just replace those with spaces. That'll ruin kind of my paragraph issue, but it is something that we would like to deal with. And I think using a regular expression is a good way of handling that. And so that's a good place to start for next time. We can use regular expressions to clean this up ever so slightly. But let me show you one more thing. So this tokenizes broadly into sentences, as you can see. What is it? It's quite too funny is one sentence. I am sure you would never guess how I employed my morning or what I ended up doing is a sentence. And so we'll, again, want to deal with these new lines at some point, but that'll have to wait till tomorrow, I think. But I can also tokenize into words. So tokenize into words. And here I'll say words equals Nltk dot word tokenize. And I'll give it tokenize text. And in this particular case, let's go ahead and print words. And I'll go to say 150. Well, actually, let's say 2000 to 2100. So this will give us the 2000th to 2100th word, not inclusive of that last one. So this will take a second. And then it says his shelves, period, quotation mark, elgo, comma, elgotten's here we are. So you can see the word tokenizer is actually much, much better at dealing with new lines and dealing with punctuation, right? So often we're actually not really going to be we're not going to be using the sentence tokenizer too much. We're only going to be using word tokenizers. And one of the nice things about this tokenizer is that it has a language parameter, and it'll use a different tokenizer depending on what language you actually want to use. So you can, for example, use a French tokenizer that takes into account the grammatical rules of French, which is great. I don't believe it has a Chinese tokenizer, but I'll show you a Chinese tokenizer tomorrow as we kind of talk about this process of breaking things apart into words. I have a few minutes left, and I think the only thing I want to do now is just very, very quickly show you one thing that's very nice about the Natural Language Toolkit. And that is that once you have a list of words, it has a bunch of handy little tools that lets you analyze your text. So I'm going to say my document, and this is going to equal nltk.text with a capital T words. So what this is going to do is it's going to take a list of words and it's going to create a Natural Language Toolkit text document that has a lot of nice things going on for it. So for example, I now can say my document.concordance, and I'll give it Holmes. And if I run this, it will give me a concordance for Holmes. So for example here, it simply finds inside of this text every time the word homes takes place, and it shows us the context around that. And so that is, a pretty useful thing to do. So this is something that the Voyant tools, for example, will do for you. You can, expand this a little bit by looking at, if you say width equals 50, that'll tell you how many characters on either side of the word you're going to look at. And you can also say lines equal 25. That's how many results you're going to get. That's a pretty handy thing to know how to do. There are lots of other things that this text object can do, and I encourage you to kind of check it out. One thing that I think we'll end with is a dispersion plot. So I'm going to say my document dot dispersion plot, and inside parentheses I'm going to say, let's say murder and death, because remember, these are detective stories and perhaps he is investigating murders, right? So when I run this will actually produce a plot for me. And this plot will show me where these terms occur across this document. And you can actually see, this is what's known as a lexical dispersion plot. And you can see that actually the first half of the collection is much more interested in murder as a concept than the second half is. But then death in the collection is actually kind of a constant. And so you can put in whatever words you want here, and it will kind of show you information about it, right? So, for example, we could use this for characters, and we could say, instead of that, we can actually say something like Holmes and Watson and Lestrange. I think that's one of the detectives' names here. I don't actually remember for sure. And apparently it's not, but we can see Holmes shows up all over the place, Watson a little bit less so. And so immediately we now have access to a pretty flexible way of studying our documents, okay? We're going to get a little fancier next time. We're going to get into making our own visualizations for some of these things, and we're going to talk about dealing with different languages. And we'll talk, and as part of that, we'll talk about stemming, lemmatization, and tokenizing. And that's going to be it. That's going to be kind of a real quick basic intro to text analysis in Python. And my hope is that I will have introduced enough that you're really excited now about the possibility of things that you can go out and do. But this by itself is a way of quickly exploring a bunch of texts. So we could adjust this code if we wanted to run across all of our different documents and save plots for all of the books, and then we can compare them. Lestrade, thank you. That is the name I was looking for. All right, well, wow, it's almost 3 o'clock. Does anybody have any questions? And of course, there will be time for questions next time as well. But we're running out of our time together. And then another question might be, is there interest in a more advanced workshop in the future? Right? We could get more into things like topic modeling and word embeddings. We could get into text classification, machine learning. The world is our oyster, as it were. And of course, I have limited time, particularly going into the semester now, but I do want to keep these going. We will get to classical Chinese, yes. The issue is that there aren't many good classical Chinese NLP tools out there. There are a few, and we'll talk about them tomorrow, but not many. Is Latin implemented in Nltk? That is a good question. I don't know for sure, but it is definitely implemented in the classical language toolkit. So the CLTK. And CLTK is designed to act very similar to Nltk, and so it's a very good option. Yeah, good. So a more advanced workshop would be useful. Glad to hear that. especially with Nltk. Yeah, there are a lot of functions that are available in Nltk, and I've just showed you two very, very basic ones, but there are frequency distributions, and you can get all of the unique words. You can do all sorts of very, very cool stuff with it. It has kind of been displaced by things like Spacey, which is, I think, a little bit more, I don't know, it relies on less hand-coded rules, I think, and more on machine learning. But we'll talk a little bit about that tomorrow as well. Okay? If that's it, it is now 3 o'clock, and I actually, unfortunately, have meetings to get to. So I'm going to have to call it there, and I hope folks join me again tomorrow for our final session, where we're going to really start to dive into some of these nuances and do a little bit of visualizing word frequencies. So take care, and hopefully I'll see some folks tomorrow and talk to everybody soon.